Unit 4, Lesson 5 test. Number 1. Rika conducts an experiment with a radio-controlled toy car. The sketches show her findings. What is the average acceleration of the car? A. 5 meters per second squared. B. 10 meters per second squared. C. 15 meters per second squared. Number 2. A car travels in a straight line. The driver applies the brakes and comes to an abrupt stop. During braking, what happens to the velocity and acceleration vectors? A. They point in opposite directions. B. They point in the same direction. C. They are at right angles to each other. Number 3. What is acceleration? A. The direction of motion. B. The rate at which velocity changes. C. An object's speed multiplied by its mass. Number 4. Measuring acceleration requires appropriate units. Which are the SI units for acceleration? A. Newtons. B. Meters per second. C. Meters per second squared. Number 5. Katrina rode her bicycle to the library. The following graph shows part of Katrina's ride after she started. What was Katrina's acceleration during the time represented on the graph? A. The acceleration was 0. B. The acceleration was 10 meters per second. C. The acceleration was 10 meters per second squared. Number 6. Which of the following is an example of an acceleration vector? A. 5 meters per second. B. 5 meters per second squared. C. 5 meters per second squared south. 7. How can you find the average acceleration of an object? A. Divide its distance by the time it took to travel that distance. B. Subtract the final position from the initial position and multiply by change in time. C. Subtract the initial velocity from the final velocity and then divide by the change in time. 8. Elizabeth is a wildlife biologist. She traveled by boat to the Everglades to observe alligators. The following graphs show the motion of her boat at several times during the trip. Which graph shows her boat traveling when it is not accelerating? A. Graph A. B. Graph B. C. Graph C. D. Graph D. Number 9. An experimenter records data for the speed and time of rolling carts traveling along a straight track. The table shows the data for 4 trials. In which trial did the cart experience the greatest average acceleration? A. Trial 1. B. Trial 2. C. Trial 3. D. Trial 4. Number 10. An experimenter records data for the speed and time of rolling carts. 4 different trials were conducted. The table shows the data for all 4 trials. In all trials, the cart accelerated. In 3 of the trials, the cart moved in a straight line. In which trial did the cart experience a centripetal acceleration? A. Trial 1, B. Trial 2, C. Trial 3, or D. Trial 4. Number 11. Which scenario does not describe the example of acceleration? A. A car decreases its speed while driving straight ahead. B. A car maintains a constant speed while turning to the right. C. A car maintains a constant speed while driving straight ahead. Number 12. Julie is in a car with her father. The car is undergoing just centripetal acceleration. What is happening to the car? A. The car is changing direction at a constant speed. B. The car is changing direction and speeding up. C. The car is stopping suddenly. D. The car is slowing down. Number 13. For an investigation, a student measures the speed of a cart as it rolls down a ramp. The student then records the data shown. It is traveling 10 meters per second at point A and traveling 50 meters per second at point B. It takes the cart 4 seconds to travel the distance between point A and point B. What is its acceleration? Number 4. 4 meters per second squared. B. 5 meters per second squared. C. 10 meters per second squared. Number 14. For an investigation, a student measures the speed of a cart as it rolls down a ramp. The student then records the data shown. It is traveling at a speed of 200 meters per second at point A and is traveling 50 meters per second at point B. It takes the cart 5 seconds to travel the distance between point A and point B. What is its acceleration? A. Minus 10 meters per second squared. B. 30 meters per second squared. C. Minus 30 meters per second squared. Number 15. What was Katrina's acceleration during the time represented on the graph? A. Acceleration was 0. B, acceleration was positive. C, acceleration was negative.